Yadukuma from my school, Jalahalli, Bangalore. So my project is the Maxwell's anti-gravity wheel. The materials I have used are PVC pipes, bends, nylon thread, a small pipe and two CDs joined together. So here is how it works. I start by twisting the wheel, which makes it go upward. Once it reaches the top, I'll let it go. So here, the up to down movement is potential energy converted into kinetic energy, and once it hits the bottom, it goes back up, which is kinetic energy, that is kinetic energy to potential energy. You could see that each rise that happens, the height reduces. It is because loss of friction and air resistance.
My name is Rushikesh Amit Mujumdar. I am in DSK School 4th grade. Today, I am going to explain my experiment crankshaft model. Its construction is very simple and can be easily built at home. So, what's a crankshaft? Crankshaft is a mechanical device which converts linear motion into rotational motion or rotational motion into linear motion. I have made two models. One is for explaining the scientific principle behind it, and another one is for fun application. Materials needed for this model are straw, bottle, and metal wire. We can observe that when we rotate the metal wire, the straw moves in up and down direction. This shows us that rotational motion is getting converted into linear motion. Similarly, when we move the straw in up and down direction, the metal wire moves in circular pattern. This shows us that linear motion is getting converted into rotational motion. Similarly, we can make two more cranks with different size of the U-bend and observe the straw movement. We can observe that deeper the U-bend, more the straw movement. Now let's begin to our fun part, hiding kitty. We can observe that when we rotate the wheel, the kitty's head moves in up and down direction. I hope you like this experiment. You can also try this experiment and learn the science behind it like me. Thank you.
My name is Nikhil. I'm from Shimoga. I want to begin with a very interesting question. Have you ever observed a spider, especially its long legs? Do you know why a spider's legs curl inward when it dies? Well, this caught my attention, and when I found the science behind it, I found something truly amazing. Spiders use hydraulic pressure to move their legs. So when the heart of the spider pumps blood into their legs, they extend outward like this. And when the heart pulls the blood out, they contract like this. So using this simple mechanism, spiders can easily crawl forward. So when a spider dies, there will be no pressure left in the system, and hence the legs curl inward automatically. So welcome to my model.
This is the final one. It's done.
And welcome to Raman Awards. So let's move on to the main concept. What is hydraulics? It's the study of how fluids behave when they are in motion and how that motion can be used to create mechanical functions. The word hydraulics comes from the ancient Greek words hydar meaning water and alis meaning pipe. It all started in 600 BC when the ancient Egyptians used hydraulics to irrigate crops. The early inventors of hydraulics were Blaise Pascal, Joseph Bram and Daniel Bernoulli. In 1653, Pascal established Pascal's law of hydraulics, which states that any pressure applied to a confined fluid is transmitted uniformly in all directions throughout the fluid, regardless of the shape of the container. Now let me demonstrate it. So as you can see, I am applying pressure and the fluid is being transmitted throughout the tube and it pushes the other end out. So hydraulics can also multiply force. A small push can lead to a much larger output, and it's used in everyday applications like hydraulic excavators, jacks and hospital beds, and even nature uses it like spider legs and earthworms for movement. Apart from building the model, I truly enjoyed experimenting with syringes, pipes, water, and testing each movement. And I would like to say that the future of hydraulics is bright. Thank you.
I'm Demistri from Navratna Higher Secondary School, Sama, Vadodara, Gujarat. So today I will be explaining you measuring lung capacity through household equipment and validating the results to the standard pulmonary lung test. But before I start explaining, you have to understand my aim of building this. So during COVID, people's lung capacity dramatically decreased and people were wanting to do their lung function test, but it was too costly for them. So I developed the lung function test with household equipments. So first of all, for this we will need a bucket with 5 liters of water, a 2 meter long plastic tube with 0.5 mm opening. Then we will need a graduated flask and a water bottle of 2 liters with a 2 centimeter opening. Now, first of all, you need to find out the BSA, that is body surface area. Body surface area equals to square root of weight in kgs multiplied by height in centimeters divided by 3600. My height is 141 centimeters. My weight is 36 kgs, which is 36 kgs, and my weight is my body surface area is 1.18 meters square. And now I have to find out the expected vital capacity. Expected vital capacity equals to, there are two formulas. One is for males and one is for females. So first for the males, the body surface area of males equals to the expected vital capacity of males equals to body surface area into 2500, while for females it is body surface area into 2000. So my expected vital capacity comes 2950. So now we have to find out the tested vital capacity. For this, I will open this water bottle. You take this tube, then insert it inside this. Insert it inside this, then close it. I'll close it, and without spilling any water, I'll keep it inside. But the water is not coming outside, as you can see. Why? Because there's more air pressure inside the water bottle than the outside. But air occupies space. So what will happen when I exhale in it? So now I'll take out the pipe. Then after I take this out, I'll measure this in a graduated cylinder. That's it. Now I'll close this water bottle, and as you can see, I have almost 840 ml of water is there inside this. Now we'll see. I think 840 can be rounded off to 850. So 850 comes here. So we'll see 850 goes to 2500. So 2500 is my tested vital capacity. So my percentage. Now we have to find out the percentage. How to find out the percentage? Percentage equals to tested vital capacity minus divided by the expected vital capacity into 100. That will come 84 to 85%, and any reading above 80 is normal. Thank you.